All right. Today, this video is the conclusion of Unit 2's video. This is the last one, and this is the test review. So after today, you will be able to just really show mastery of Unit 2. And we're going to go one section at a time, just like a faster pace. So if you haven't watched any of my videos for any of Unit 2, this is kind of like a brief overview. Know that this is not a replacement to watch all the other videos, but it's just kind of like a review, hence the title. So let's get started. Problem 1. Solve the equation below. Check for extraneous solutions. So first things first, I have to write my 4 steps. Well, I guess it's 3 if you're in my class, but there's really 4 steps that you need to do. Step 1 is to get absolute value alone. Step 2, plus slash minus. Step 3, simplify. And step 4 is check. So solve the equation below. So step 1 is already done because there's nothing to the left, there's nothing to the right of my absolute value. My absolute value sign is the biggest sign that I have, or the biggest thing, like the most outside of one side of the equation. So now I have to make a positive and negative version. And so I'm going to start step 2 here. 2x plus 5 is equal to 3x plus 4. And 2x plus 5 is equal to negative 3x plus 4. And note that I put this in parentheses for the negative version because it's going to turn out to be this. I have to distribute the negative. So that is important that you understand that. And now we just solve it like a regular Algebra 1 question, where I can subtract 2x on both sides. So that's going to be x, and subtract 4 on both sides. 1. X is equal to 1. Nice. And this one is, I'm going to add 3x on both sides. That's 5x. And I'm going to subtract 5 on both sides. Is equal to negative 9. So, divide 5 on both sides. X is equal to negative 9 over 5. So, yes, these are both like your correct answers for now, but we have to check them for extraneous solutions. And you should be doing this every single time that you have any kind of question whatsoever about absolute value and solving it. So a good way that you should check this is by using Desmos. So I can do absolute value of 2x plus 5 is equal to 3x plus 4. So you see how this line is flat? That's pretty much saying that the only choice is 1. 1 is the only thing that works. So this is my only x equal 1, and that's it. As in this negative 9 over 5, that's considered your extraneous solution. And I'll write that as ES, extraneous solution. So this doesn't work. Let's try number 2. Number 2 is a little bit harder because now we do have to do our step, which is step 1. Or sorry, yeah, we have to do step 1. Step 1 is that we have to get rid of everything that's to the left and to the right of the absolute value sign. So I'll label this step 1. So I'm going to add 2 on both sides. So that's 3. Absolute value of 2x plus 4 is equal to 6x plus 30. Divide that by 3. So 2x plus 4, that is absolute value, is equal to 2x plus 10. Because 6 divided by 3 is 2. 30 divided by 3 is 10. Now I can do my second step, which is making the positive and negative version. So I'll do this here. 2x plus 4 is equal to 2x plus 10. And I have 2x plus 4 is equal to negative 2x plus 10. Now I have to distribute the negative right here. So it's going to be 2x plus 4 is equal to negative 2x minus 10. Let's start with this side right here, which is going to be step 3. I guess this is also step 3 right here. So I subtract the 2x with the 2x. And if you have $2 but you owe me $2, you have $0. That's 0 x's. So I'll write that here. And I want to get my 4 on the other side for fun. So 0x is equal to 6. So is 0 equal to 6? Because isn't anything times 0 supposed to be 0? So this statement doesn't make sense. So I would write here, does not work. Okay. What about this side? If I add 2x on both sides, that is 4x, and I subtract 4 on both sides, is equal to 14. Divided by 4, that is x equals negative 7 over 2. So if I put this all into Desmos, 3 times absolute value of 2x plus 4 minus 2 is equal to 6x plus 2. Alright, 28. Let's take a look. Where is that? My solution is right here, negative 3.5. Negative 3.5 is negative 7 over 2. So if I write negative 7 divided by 2, that's negative 3.5. So that makes sense. So yes, this is a solution. So step 4, oh, right here. Check on Desmos. Let's look at number 3. Number 4, it's really testing you more about your algebra skills now than your absolute value skills, because you're taking the same steps. It's just now your algebra is getting harder, but really you know all of these things. You know that the way to get rid of square root is to square, because they're opposites. Kind of like adding and subtracting are opposites. So I'm gonna square both sides, and I know that I have to square root first because the the square root sign is covering every single thing. So I can't touch the 5 and the negative or the minus 4 without subtracting or without squaring both sides. So I have 5 times the absolute value of x plus 2 minus 4 is equal to 4 squared is 16. And how come I did not square like my negative 4 or my 5? Because this square cancels out this square root. And that's why I have this left over. Okay. And doesn't this problem look very similar to the problem that we did just now? Where I have a thing on to the left and to the right. And that's true, and I still need to continue. Which would be to add 4. And the reason why I add before dividing is because in PEMDAS, we have to go opposite order of PEMDAS to undo something. And the reason why that is because we have a variable here. Opposite order when there's a variable. So 20 is equal to 5 times absolute value of x plus 2. Divide by 5 because that's doing the inverse operation. So absolute value of x plus 2 is equal to 4. This is something that you are very comfortable now. Because now I can just do my second step, which is making a positive version and making a negative version. Subtract 2 on both sides. X is equal to 2. X is equal to negative 6. So, let's say for example, you don't want to write all this junk into Desmos. You don't have to. You can type this in. You can type this in instead, because watch, 5 absolute value of x plus 2 is equal to I guess I don't need the 5, is equal to 4. So let's scroll out and let's see. Okay, now I have 2 things right here. Let's look at my other equation when I write out all of it. So square root of 5 times absolute value of x plus 2 minus 4 is equal to 4. You see how both of these graphs are the same? And that has to make sense because me doing step 1 to step 2, between that, all I'm doing is making the graph, or like making our function looks easier to type, look easier to like do algebraically. We're just telling you that it looks so clunky now, I need you to make it look cleaner. So your skill from step 1 to step 2 is to make it look cleaner before you take the absolute value. And our graph shows right here it has negative 6 and it has 2 as our solution. And these are the 2 things that we have highlighted here. So yes, x does equal to and negative 6. And step 4 is to check. I guess it's right here, step 3. Step 4, or problem 4. Solve the equation below, check for extraneous solutions. So same thing, the 4 steps that we're going to do. But what do I do here? And if you are thinking correctly, well, I hope you are. You're either stuck between 2 choices, getting rid of the 6 or getting rid of the 3. And remember what I said, you always want to do the opposite order of PEMDAS, right? So that means that adding and subtracting has to go first, then multiplying and dividing goes second, the E goes third, and the parentheses go fourth. So the first step should be to get rid of this minus 6 by adding. So y plus 3 divided by 3 is equal to 4. And yes, this looks scary because we as mathematicians have been raised to be fearful for fractions, but really this is just the same as writing it like this. Y plus 3 is being divided by 4, or by 3, sorry. And we know that dividing by 3, the opposite, or to undo this, is to multiply by 3. So I'll just write multiply by, I'll write this like that. And that means that I have to do it on this side as well. Y plus 3 is equal to 12. Oh, this is absolute value, sorry. And now I finished step 1. Now I have to do step 2, which is making my positive and negative version. And this looks very simple now because I have a number by itself and I have my absolute value by itself as well. So y plus 3 is equal to 12 and y plus 3 is equal to negative 12. Subtract 3 on both sides. Y is equal to 9. And subtract 3 on both sides again. Y is equal to negative 15. And that's not it, right? I need to check for extraneous solutions, and that's step 4. And I don't want to type this in. And if you type it in the test, sure. But you can save so much time by not typing this in. Do not type this into Desmos. Use this for Desmos. And really, this is just being you just saying, hey, I'm efficient because I'm going to type this in because it's easier to type, which is true. So if I type this in, absolute value of, I'm going to just use x for fun because I like the variable x for Desmos, and I think Desmos likes it too. So if I scroll out, I see that this is, I'm going to use y equals 0 just so that I can highlight the intersections. So you see how this is negative, this is 9, 0. So this is correct, or this works. And then the next one is right here. This is, oh, this is negative 15. So this works. So this works. So y is equal to both negative 15 and 9. So hopefully that made a lot of sense to you. Also note that from 2.1 we learned how to do the word problems. So let's read the question and then let's review a little bit and then I'll solve it. In Houston, Texas, the average high temperature during the month of December is 65 degrees. The actual December temperature for Houston may be about 5 degrees warmer or colder. What equation can be used to find the minimum and maximum temperatures? So we have to think 65 is like the middle, but it can be 5 degrees warmer. So isn't that 70 is warmest? And the coldest would be 60, right? So in my head, I'm thinking that 65 is the middle. Or the start. Because in this question, we're talking about 65 being like the difference maker, or that's like the starting point before we add or subtract this 5. So remember the equation, x minus start is equal to variance. We talked about how the variance is the number that we're adding or subtracting. So we can just substitute these for values. X minus 65 is my start is equal to variance, which is 5. That's it. So the skill that you're learning in this question is, how can I evaluate a word problem or like a scenario and make it into an equation? Because if I try to solve this problem again, it would look like this. X minus 65 is equal to 5, and x minus 65 is equal to negative 5. And to get rid of the things next to the x, I have to add 65 on both sides for both of the equations. So x is equal to 70, x is equal to 60. And isn't that really what this is right here? It is. So this equation makes sense. Number 6 is really hard, and I want you guys to ask me questions about this if you don't understand this during class. So it's up to you to understand it or not. Number 7. There are two different points on the number line that are both 5 units away from the point -2. Write an equation that gives these 2 points as its solution. So if I draw a number line, and I say that -2 is my middle because it says 5 units away from point -2. So if I count 5 units to the positive side, this is +3, right? And 3 is equal to x. On this side, we would go 5 towards the negative direction, so this would be -7. This is also equal to x. So remember, the equation is absolute value of x minus start is equal to variance. The variance is the amount of steps that we took to get to this, which is 5. So this is 5. The start is the middle between the 2 points that we end up with. So it's absolute value of x minus -2. But I can write this better. I can write this so that my double negative becomes a positive. As in, if I say in English, I don't want to stay awake, doesn't that mean that you want to sleep? Yes. So absolute value of x plus 2 is equal to 5. Number 8 is another like practice problem that has the same exact steps, just different numbers. Same, but different numbers. So I'll pause the video now. In 5 seconds, I'm gonna give out the answer. In 5, 4, 3, 2, 1. X plus 6 is equal to 3. There you go. Number 9. For what value of x is the expression equal to 0? And what they're saying here for number 9 is saying, hey, I have this absolute value equation. Set this equal to 0. That's all they're saying. So really, this question is just like the first question. You just gotta move the 5 or anything beside to the left or the right of it to the other side. So the absolute value is alone. So 5 minus x is equal to -5. This is a special note here because I noticed that I have a negative by itself. You cannot have a absolute value equal to a negative number. And that has to make sense because we said that absolute value of a negative number turns positive. And I said that an absolute value of a positive number turns into the same thing, a positive of the version of the number. So what this is trying to say is that cannot turn out negative. So in the end, really, this is no solution. But what about this one? If I add 3 on both sides, this is absolute value of x minus 3 is equal to 3. I can solve this one by making a positive and negative version. By adding to get rid of the 3 next to the x. So x is equal to 6, and you add 3 on both sides, x is equal to 0. So this is true. Number 10. write an absolute value equation that has the given solutions -2 and 8. So the hint says, think about the midpoint between -2 and 8. So if I draw a number line, and I have -2, and I have 8, what is the middle between these? What is the midpoint between both of these points? Because didn't my question in number 7, isn't -2 in the middle of -7 and 3? Because if I took 5 steps to the left and 5 steps to the right from -2, isn't that 10 total steps? So I know that this thing and this gap have to be the same. So what you can do is do -2 to 0. This is 2 steps, right? And 0 to 8. This is 8 steps. And you add them together, that's 10. So 10 divided by 2, because this 10 is talking about the whole distance between the -2 to 8. So to find the middle, I have to divide it by 2, which is 5. So this point has to be 3. So that means that these steps right here, these are 5 each. Because if I count, it goes -2, -1, 0, 1, 2, 3. 5 steps. 3, 4, 5, 6, 7, 8. That's 5 steps. So this makes sense. So I can make the equation, which is absolute value x minus start, which is the 3, is equal to the variance, which is 5. Alright, this is where things get juicy. 2-2. 2-2 is going to be talking about solving, again, but instead of equations, we're solving inequalities. And know that the inequalities, they're talking about what to do with the inequality facing towards the absolute value and the inequality facing towards the non-absolute value, or facing away from the absolute value. Oops. Sorry, I got the hiccups. So, just a reminder. What? Okay, just a reminder. I'll write it up here on the page. The absolute value x is less than a. We do it like this. Negative a is less than x is less than a. And when x is, or the absolute value of x is greater than a, it is x is less than negative a, and x is greater than positive a. So in this question, this inequality is facing towards our absolute value. Jesus Christ. My hiccups are bad. Okay, I think I'm okay. So our steps still apply, where we do the same question, or the same steps as 2-1, which is get the absolute value alone, which is done. So step 1 is done. Step 2 is to make the positive and negative version. And this is where step 2 is different from 2-1 and 2-2. Because now I can make x, sorry, not x, you would write the equation 4x minus 3 is less than the negative version of this, which is 5. Oh, I forgot my absolute value sign. And then I would do, wait, I don't need the absolute value signs. Boop, my bad. And then you have 4x minus 3 is greater than the positive version of this, which is 5. And now I just solve it like an Algebra 1 question. This is the most important step. If you mess this step up right here, you're going to get the question wrong. Where's my cursor? There it is. So I got to add 3 on both sides. So 4x is less than negative 2. Divide by 4. X is less than negative 1/2. And I'm going to just draw this like right here. Sure. Oh, it's not a closed circle. It's an open circle. And the reason why it's an open circle is because of this. So I'll draw an arrow for that. My arrow's ugly. There you go. Negative 1/2. So I'm going to do the same thing here. Get rid of everything next to my x. Or simplify. So 4x is greater than 8. Divide by 4. Why did I divide by 2? X is greater than 2. So this is, if I'm going to stay in units, this is 0, right? 1, 2. So this is 2 right here. And this is also an open circle because of my inequality. So if my x is greater than 2, isn't 3 greater than 2? Yes, because this 3 is right here. So my arrow, or my shaded solution, is going towards the outside. And if x is less than negative 1/2, if x is 1, which is right here, negative 1, negative 1 is less than negative 1/2. So that makes sense. So I know that my solution is going to be towards the outside of my circles, or my solutions. So you do have the equations, and you have the number line. Number 12. I'm going to let you do number 12 because it's very similar to number 11. So these are similar. Because I don't want to make this video too long because you guys complain. But instead, I'm going to do number 13, which is a harder problem. Because 13, it's hard because I have these things next to my absolute value. My absolute value is not alone, so I need to apply step 1. Which really isn't that hard, it's just more work. You just have to understand that you do need to know what steps to take first. So 4 times the absolute value of n minus 2 is equal to 36. Divide by 4. Absolute value of n minus 2 is equal to 9. Not too bad. Oh, it's not equal to, sorry. So this right here is actually supposed to be less than, so this is less than 9. So n minus 2, and if I look up here, you see how my absolute value, my inequality is not facing towards it, so I use this version right here. My absolute value is less than a, and I'm going to use this right here. N minus 2, and I'm going to draw my inequalities facing the same way. I'm going to make a positive version and a negative version. And if you remember, I do the same operation to the middle, to the right, and to the left. All 3 parts. So if I rewrite this, negative 7 is less than m but that is less than 11. So let's shade this in. If this right here is -7, then this is, let's just say right here, this is 11. I don't want to count. Whatever. This is negative, or this is positive 11. So if you see how the M is between, M is between -7 and 11. So you can say that all this between is also true. And this is why I like writing it like so. I like writing it like this because it helps me as a student, or it helps you as a student, that my solution is between -7 and 11. As in, if I write like something between that, like 0, -7, 0 is greater than -7, right? And isn't 0 less than 11? That's true. So that's why I like writing it like this, because it's like a nice reminder that I don't need to do this step to prove that my solution is correct. Number 14. In-state tuition for an incoming freshman at Texas A&M is listed as $11,036, but the actual tuition could differ from an average by as much as $2,025. Used the inequality, absolute value of x minus $11,036 is less than or equal to $2,025 to determine the range of the tuition an Aggie freshman could actually pay. So they're saying that this equation right here is portraying how much an Aggie can pay. So really, this question is saying that you have this inequality, figure out how much a person is going to pay if they went to A&M. An Aggie is some like a, you are like a Trojan because you go to Newman Smith High School. That's our mascot. So A&M, they call themselves Aggies. So what do we do here? Really, we just do the same thing that we did for 13 and 12 and 11. We just solve, because we can figure out an inequality to determine and to show or to illustrate what could happen or how much money you can pay. So my absolute value, my step 1 is done, right? So if I'm confused, I know that my inequality is facing away from my absolute value. So I can look at it like so. Negative 2,025 is less than or greater to, or less than or equal to, sorry, x minus $11,036. But that is also less than the positive version, which is, why did I put the comma here? Like so. Okay. So I do all this, and the only way for me to get rid of my absolute value, or to get my x alone, is to add this $11,036. So this becomes $9,011 is less than or equal to x, which is less than or equal to $13,061. That's it. That's all you had to do. You had to understand that this question is pretty much asking you to solve. Alright, 2, 3, 2, 4. This is kind of like a wombo combo way of us condensing our review, because really 2, 3, 2, 4, they come together very nicely because they're talking about the graph. So 2, 1, 2, 1, 2, 2 talking about solution solving, 2, 3, 2, 4 talking about the graph. So what is the vertex of the graph? We know that the equation is y is equal to absolute value of x minus h plus k. I guess you can put an a here. I have this negative right here. So what I really want to do is switch this thing from looking like the original and really factor out that negative. So negative x minus 5, close my absolute value, plus 7. So my vertex is going to be 5, 7. And let's see if that's true. Let's see if Mr. Hong understands what he's doing. Because Mr. Hong can still make mistakes. Y equals to absolute value of negative x plus 5 plus 7. Oh, look at that. The vertex is 5, 7. Nice. Just know that the vertex is like the point where it turns significantly. So yeah. Which quadrant is the vertex of the graph located? This is going to be, well, if I draw like a miniature one, this is 1, 2, 3, and 4. So my vertex is here-ish, right? So it has to be quadrant 1. What is the equation of the axis of symmetry of this graph? So the equation is x is equal to your h from the same problem, which is up here. My h is 5 because isn't my vertex hk? Yeah, so really this turns into x is equal to 5. Pretty simple. But the last one's kind of hard because it's telling you to list out all the transformation rules, as in what happened to my graph from the parent function, which is like the plain Jane version, from the green graph to the blue graph. So if my vertex right now is 0, 0 and it becomes 5, 7, I can think in my head it went up 7 units. It went to the right 5 units. That's at least what I know. Because how am I supposed to go diagonal? I can't go diagonal. I have to go up and to the right. So I have to go up 7 units. I have to go right 5 units. Hence the rise over run, or the rise and run way to figure out coordinates. Okay, we have one last thing to think about, and I'm going to draw this in red because I need to talk about this right here. I need to see that this right here is talking about reflecting over the y-axis, because this negative is inside my equation, my absolute value. So this is reflect over y-axis. And I'm going to write a side note because the negative is inside the absolute value. Write the equation of the function graphed above. Well, it should really say it below, but you know what I mean. So in this problem, instead of giving you an equation, they gave you a graph, and this might be harder because you can't start off by graphing this. Like for test, If I gave you this, I pray that you use Desmos and you just figure out that the vertex is this coordinate, you figure out that the line of symmetry is this line, so on and so on. But now that I don't have my thing, I don't know what's going on. But I do know that my parent function is supposed to look like this, right? I cannot draw straight, but this is pretty much like just like a vague way of drawing this absolute value line. I can't draw straight because my pencil doesn't track that well. So how many steps did I move upwards? How many steps did I move left or rightwards? I went up 1, 2, 3, 4. So I went up 4. I went 1, 2, 3 to the right. I didn't reflect over the x-axis or the y-axis. That'd be very mean of me to do so. But it could happen. Hint, hint, wink, wink. Because this is a review. So this is the absolute value of x minus 3 because of this. This is the minus 3 part right here. I'll write it in a different color. Plus, and I'll write this as a 4, and I'll circle this part. Because the going up 4 is responsible for this k part, and the 3 is responsible for going right 3 units. So now it's going to be asking me attributes for this. Pretty simple, right? Because we know that 3, 4 is my HK, which is my vertex. Because this thing right here, this is my vertex right here. And just to make sure that you see it, I'm going to draw it in red as well. So what coordinate is that? That's 3, 4. And it's located in quadrant 1. Because the quadrants go like this. You don't need to draw this. It goes 1, 2, 3, 4. So it's here. So this is in quadrant 1. The axis of symmetry is x is equal to h, which turns out to be my h is 3, which is for my vertex, which is x is equal to 3. You have to write the x equals 2. And the reason why is because the axis of symmetry, that's a line. You cannot just draw, you cannot just write 3. I'll draw it red. So the axis of symmetry looks like this. Because this line is showing the line of reflection from the left to the right. Or the right to the left. We're saying that the left is equal to the right on the axis of symmetry for that graph. What about the domain? If I draw a compass, kind of like how I taught you guys in the beginning, I have north. So this is going northeast, and this is going northwest. So I got my north, I got my east, I got my west. I do not have my south. So my domain and range, or my domain is good because I go to the west forever, which is representing negative infinity. I'm going to the east forever, which is positive infinity. So I have negative infinity to infinity for my range, or my domain. But my range is kind of weird because I go to positive infinity forever, right? But my lowest point isn't negative infinity because I don't have an arrowhead going southbound. My lowest point on this graph is actually my vertex. What is the y value of your vertex in this question? It is 4. And yes, we use a bracket because we include that because you see this line right here? This is solid. This is a solid dot. These are solid lines, right? Therefore, we use a bracket because we include it. Nice. The intercepts, really, I don't have any x-intercepts because my graph is too high. But my y-intercept is 1, 2, 3, 4, 5, 6, 7. So it's 0, 7. Minimum and maximum. Know that this is talking about smallest, and this is talking about largest. And what this is saying, between 1 to 4 for x values. So between the x value 1 and 4, when is it the smallest? And how tall is that? How tall is the smallest? So let's see. From 1, which is here. I guess I'll write it in a different color. Have this purple, nice. So 1 to 4, right here. When is it the shortest? It would have to be here. My shortest is y is equal to 4, which is actually my vertex. My vertex is within these boundaries. So my vertex is my lowest. That's true. I've already said that in my range. This is the lowest. This is the largest. So my vertex is in my boundaries or my interval. So it makes sense that this is my smallest y value. But what is my largest y value between 1 to 4? So I have this right here. This is 4, 5, 6. And this right here is 5. So this one is bigger. So I could just write y equals to 6. You can also write it like this. 3, 4. Or you can write this as 1, 6. (17) If f of x is equal to absolute value of x, how will the graph change if you have this equation? So it's pretty much it's asking you to list out the transformations, kind of very similar to what this is right here. So you have to know for you to understand this, you have to understand this is 2, 4. This is 2, 4 for sure. As in, what does this do? What does this do? What does this do? So anytime there's a number, you need to figure out what does this do to the graph. Let's start with the easy one. The -4, that's going down 4 units. The +6, that's actually going to the left 6 units. We have to think of opposite, going towards the opposite direction. So in your head, you're like thinking, oh, positive, it must be going towards the positive direction on the x line or the x-axis. That's not true for the x. For the y, it's true, but for the x, it's not. And this 0.25, that is a vertical, I guess I'll write it out because it's a review, compression by 0.25. As in, I'm compressing it of a scale factor of 0.25. What quadrant is the vertex of the graph? So I'm going to draw the I'm going to write the quadrants again. 1, 2, 3, 4. And my vertex is -6, -4. So isn't that dot like somewhere around here? So it has to be 3. You would write it normally in like Roman numeral, so I will. 18. If f of x is equal to absolute value of x, how will the graph change if this equation, which is -4 f of x plus 5 minus 1, How will the graph be wider or narrower? List out the transformations. So, first of all, is it going to be... Know that wider is to vertical compression, and narrower is talking about vertical stretch. And this is talking about getting fatter or like wider, as you can tell by the word. And narrower, that's the same as getting skinnier or faster. So if I multiply by 4, if you say that you run 10 miles per hour, which is insane by the way, but if I say that, okay, you run 10 miles, I run 40 miles faster, is that gonna be, is my line going, like if my running time was graphed, wouldn't my graph be like shooting up higher than your graph? Yes. So narrower is the correct answer. But that's not it. I told you to list out all the transformations. The transformations are here, here, and here. Pretty much all of my numbers. So I'm going down 1 unit. I'm going to the right 5 units. I am vertical stretching by 4. And I'll have a negative. And that's going to be a reflection on not y-axis, sorry. On x-axis. And that is because the negative is outside. And that's the only reason why. If it was in the inside, kind of like before, where is it? Here. This negative sign is inside the absolute value. But this negative right here is outside of the absolute value. Kind of. 19. Determine the intercepts, axis of symmetry, domain, and range of the function f of x is equal to negative, well, it's really negative 1 times absolute value of x minus 2. So if you didn't know, the domain is going to be all real numbers always. And really what your answer choice is going to look like is this. This is just like a abbreviation for it. So I guess you don't really need to see that. Your range. So is your graph facing upwards like this, or is it facing downwards like this? Which one is it? It's actually facing downwards because of this. This outside negative is reflecting on the x-axis. The x-axis is the left to right line. So my range is actually going towards negative infinity because my arrowheads are going southeast and southwest. So I'm going towards negative infinity, and the tallest y value I have is this right here. My tallest y graph is, or my tallest y value or largest y value is -2. My axis of symmetry, or my AOS, that's x equals h. In this question right here, which I'll rewrite because I defiled it, negative absolute value of x minus 2. I really can turn this into negative 1 times absolute value of x minus 0 minus 2. This part right here is understood, as in I don't need to write this down. But this right here, that's my h. So what this turns into right here is x equals 0. And my intercept, this is the time where you would graph this. Negative absolute value of x minus 2. My intercept is right here. 0, -2. And while we're graphing it, let's just check our work. My domain looks like it's going east, it's going west, it's going east, so that's true. My range looks like it's going towards negative forever, downwards forever, and it stops, the highest point is -2, which is my vertex. The axis of symmetry is x = 0. And I don't like this color. It's like I can't write it differently. There you go, now it's red. So this red line is cutting my graph in half evenly. And that's why this is the line of symmetry. If I just write 0, it doesn't, like, decimals doesn't pop up anything. So it's important that you write x = 0. It is super, super duper important. But yeah, that's pretty much it. Number 20. How much more is there? A machine fills containers with 16 ounces of grain. After the container is filled, another machine weighs them. If the container weighs different, or the weights differ from 16 ounces by more than 1 ounce, the container is rejected. Create an equation that represents this relationship. So, the question is, are you using inequality or are you using equal to? Because it says if the container weights differ from 16 ounces by more than 16 or by 1 ounce, so if it's 15, it's good. If it's 14.9, it's bad. If it's 17, it's good. If it's 17.1, it's bad. So the way that I have to represent this is like so. Absolute value x minus start is equal to variance, or margin of error. So the margin of error is 1 ounce. The start is 16 ounces. But I have this equal sign. This equal sign has to turn into a greater than, because absolute value for this question, they're saying that that it has to be like this 1 ounce has to be less than this equation, because if it's greater than, then this equation or the thing you would throw away wouldn't make any sense. So that's why this is our solution. So this is kind of like more practice. 21 I'm not going to do because this is the exact same kind of question, just different numbers. I'll write down the answers. You can pause the video and you can pause the video if you want to try this by yourself. But I'm going to write the answers in 5, 4, 3, 2, 1. Okay. So the equation is y equals absolute value of x plus 3 minus 1. The intercepts are -4, 0, -2, 0, 0, 2. The vertex is -3, 1 on quadrant 3. The domain is, I was going to write all real numbers, but I'll write it really. The range is -1 to infinity. This is y equals 2, and this is y equals -1. Okay. So this is more practice. I guess I'll do number 22. So the parent function y is equal to absolute value of x has been vertically compressed by a scale factor of 0.5. Translated to the left 2 units, down 5 units. What is the equation? Where's the vertex? Where's the axis of symmetry? So really I can just list out all of my things. So I vertically compressed by 0.5. So 0.5 is vertical compress. I went left 2 units. I went down 5 units. So this is -5. This is +2. And this is 0.5. And I know this from 2.4. This is section 2.4. So if you don't understand this section right here, or I guess like any of the graphing questions, you need to watch 2.4. So I can take all of these and I can make an equation. Y is equal to 0.5 absolute value x plus 2 minus 5. And the reason why I got +2 is because I have to think opposite from here. I have to think opposite. It's going to the right. It's going towards negative direction for my x-axis. So I have to think of opposite. My vertex, that's my h and k. This is my h, and this is my k. But I have to think opposite. So my vertex is really -2, 5. And my axis symmetry is x equals h, which is x equals -2. So this is also 2.4. So if you need help with this question, you should watch that video again of the lecture. I'm going to tell the answer in 5, 4, 3, 2, 1. Y equals to -3 absolute value of x plus 2 minus 5. Yeah, that makes sense. Okay. The vertex is the same, -2, 5, -2, -5. Oh shoot, this is -5. And the axis of symmetry is x equals 2. Same thing, -2. All right. The last type of question, and this is one of the do nows. And if you remember, well, I guess if you're not first period, then you should remember this is called a double absolute value, and there's specific steps that you need to take first. There's like conditions that you need to write, and I'll write this below here. You don't need to write the steps down if you don't want to, but you should for fun. Step 1, do the most inside operation. Step 2, do the most inside absolute value. And then step 3, repeat step 1 till finished. And what that really looks like is, so I have my absolute value, and I have so many like absolute value lines. I have a pair of lines here, I have a pair of lines here, and I have a pair of lines here. So I have 3 pairs of absolute value lines. That's not a problem, because if I look at step 1, it says do the most inside operation. So I have an inside operation here, and I have an inside operation here. Know that this is not the minus between these two absolute values. They're not the most inside. The negative right here, this is only inside the red, but the plus right here and the minus between the 6 and the 13, it's inside 2 absolute values. It's inside the red and inside each of the blues. So that's why I can simplify these first. So -10 plus 4 is -6. This right here, 6 minus 13, that is -7. I'm going to write the minus, and I'm going to draw my absolute value lines actually in the same color for fun. So that's step 1 right here. Step 2, I'm going to do the most inside absolute value. So like this -6 right here and this -7, I can take absolute values of that only because they're alone. So this becomes, if you didn't know, from 2, 1, the absolute value of -6 is 6. And the absolute value of -7 is 7. This minus sign comes down too because I haven't touched it yet. And the absolute value signs for the reds come down. Nice. And then we just rinse and repeat. I do this operation right here, which is 6 minus 7, that's -1. Take the absolute value of that, which is equal to 1. And that's it. All of this is equal to 1. And if you really want to make sure, you can use Desmos, which is absolute value of -10 plus 4 minus another absolute value of 6 minus 13. Absolute value, and then close another absolute value. Did I type that right? I did not type that right. Let's try it again. Absolute value of absolute value this is a minus, so you just gotta, I guess you just gotta play with it a little bit. Okay, there we go. Now I got it correctly. So you just gotta play with it for a little bit just to make sure that your equation looks very similar or is exact like so. And then look, it does it for you. -1 or +1, sorry. But on your test, you're gonna be required to ask. We're gonna be asking for work. So as you know, you have to take pictures of your work. So yeah. I'm gonna let you guys do 25 by yourself because this is very valuable practice. You will 100% see this on the test because this was a do now. We give value to do nows because we give you value because we know that do nows are not always fun, but we want to make it valuable for your time, so we make them like either super important in lectures or we make it a test question or similar to the test question. So I'm going to reveal the answer for this in 5 seconds. 4, 3, 2, 1. This is equal to 7. But yeah, that pretty much concludes the review. If you have any questions, let me know. Your test is on either Wednesday or Thursday. No, Tuesday or Wednesday. But yeah, good luck on your exam, and see you guys in class. Bye.